This content we will look at in this content we are going to explore the stealth technology news of the F-35B, the radar-absorbing material behind it, and its plan-formed alignment and engineering. I would also want to explain to you the basic differences between F-35B, AB, and C while looking at the engineering of STAV, or short takeoff, vertical landing, and the engine powering it, and how it works in simple animation. As fifth-generation fighter jet, we have to see the weapon system alongside the electronic warfare suite, and lastly the $400 helmet and its features. But first, shouldn't we talk about politics to the content now? This is the Lockheed Martin F-35B Lightning II. The search for a stealth fighter has spanned decades, one that can take off and land in tight confines. Martin began developing experimental vertical rising fighters as early as 1954. The Harrier was one such aircraft that had achieved this engineering feat. It was ahead of its time, but like every engineering marvel, it has its flaws. During vertical landing, it would turn over multiple times due to turbulence from its own downwash on the tip of each wing. Included a small roll, so has been the promise of the stealth fighter that can take off and land vertically. Languishing for so long, it held the hope that one day it would become a reality. The reality is, however, misaligned air directional control and a faulty elevator caused the fighter jet during deployment to be uncontrolled. Due to restriction and malfunction, many designs were thrown and replaced, and that included hoist styles and strive in having none. The nozzle in question alongside the aircraft's pilot had to participate in the manual adjustment of the control, which had to augment the automatic control in order to maintain stability of the aircraft to enable it to land. Nevertheless, the F-35B short takeoff and vertical landing system STAV was an enhancement integration of vertical landing with far aggressive range supersonic speed, making this a stealth lightning fast fighter built to hold any contemporary warfare weaponry. Let us consider the modification of the F-35 circling this up armament and armor modification. 3 were created and all were one-man seat jets. The F-35A, which the United States Air Force used, and a number of allied nations, which is better advanced for the United States forces, including the entire NATO, was made to make conventional takeoffs and landings. This type of aircraft is built for operation on standard airstrips and is the only one of the F-35 variety to have a 25mm internal cannon, enabling it to succeed F-16 multi-role fighter and the A-10 Thunderbolt II flying cannon, 10 Thunderbolt II, among other aircraft. All the other types of F-35 do not have this round in their modification. The F-35B was constructed primarily for short vertical takeoffs and landings, and was also made due to the need of United States Marine Corps. F-35B's single vertical variants make it possible for the Marines to fly their jets without requiring long landing strips or aircraft carriers. Let us review the specifications of the F-35B model in the coming sections in a little greater detail. The gross takeoff weight of the Joint Strike Fighter in the C variant is about 31 tons, which is substantially more than that of the C variant Joint Strike Fighter that weighs about 56 tons. However, the C variant Joint Strike Fighter has been equipped with some improvements that aim at increasing operational effectiveness and safety. For instance, the C variant will operate from an aircraft carrier deck, hence it has been designed and equipped with robust landing gear to assist with carrier landings. Its angled launch will be conducted from semi-deck launching points on the flight deck of amphibious assault ships. In our earlier findings, we have seen an extensive study of the U.S. Navy's operational requirements. This brought me and my team to the heart of work, where we met with men responsible for orchestrating the United States Navy's carrier strike groups. U.S. Navy's reputation as a professional fighting and offensive power that can manipulate the geography in its favor, using airstrikes launched from carriers, supported the requirement of the Joint Strike Fighter with stealth capabilities. The assistance provided includes the USS. As mentioned above, the C variant will operate from an aircraft carrier deck. Hence, it has been designed and equipped with robust landing gear to assist with carrier landings. Its angled launch will be conducted from semi-deck launching points on the flight deck of amphibious assault ships, while still being able to operate from standard runways. Parts of the fighter jet. This is the nose of the F-35, and inside it is a Northrop Grumman ANA PG-81 active electronically scanned RFI control radar, which is the world's most modern and capable radar and serves as the backbone of the F-35 Lightning advanced sensor suite. Moving back, we have the canopy, which has been plated with an indium tin oxide layer to give it a golden sheen. This helps to keep it stealthy. This is the lift fan doors of the F-35. Inside it is a Rolls-Royce lift system that offers a STOVL short takeoff and vertical landing aircraft that is exceptionally durable and dependable. The Rolls-Royce lift fan is the heart of the F-35B thrust vectoring capability. 29,000 shaft horsepower is horsepower Rolls-Royce lift fan delivered to the lift fan. The exhaust nozzle, which is connected to the main engine by a drive shaft, produces a downward flowing column of air at the front of the plane. At the back, the exhaust nozzle twists, aiming its push toward the ground for directional control. All of this is possible because of the Pratt & Whitney F135 after-burning turbofan engine has two types. The first type is used for aircraft that require CTOL capabilities, such as the F-35A and F-35C. The F-35B aircraft, however, require a more thrust-to-weight ratio, thus using a two-cycle short takeoff vertical landing STOVL model that works in conjunction with a forward lift fan. Let's look at how this works. Disassembly of the engine module involves removing the rectangular intake ramp, both of which involve sucking in air, shoving my fuel into a segment of the jet pipe where it combusts with fuel and ignition of T8 gas mixture, resulting in the second stage in the optical upper part. Both units that run the forward axis were grooved together, leading jet fuel to be conserved during the takeoff altitude. In the afterburner, once it has heated through engagement of fire, it is only turned on occasionally to engage in conflict or for ascent maneuvers after engaging in it. To commence this action, the exhaust pedals start moving, which widens or lessens the gap between them. All of this is enacted in order to decrease the weight on the turbofan engines while they are in a full dry mode with a burning throttle position. Because there are a total of 7 or 10 internal fuel compartments that provide such immense force. Let's examine where they are. The first fuel compartment is situated right past the pilot's seat. This center fuselage is known as compartment number 2, which means that it is the engine feed tank or containment number 3 fuel compartment. As we move back to the other compartment, the fuselage has 2 additional vents located on either side of the compartment, which supports the 4 wing carry compartments, which also fueling the compartments that are located on the sides called wing fuel compartments. The compartment that is compartment number 4, and to assist in supporting the fuel compartment's outline, there is a total of 2 vertical fin compartments that do vents, and these particular vents are situated on the vertical fins situated on the aircraft. Scaling back to the wing components, there are a total of 2 rudders mounted on the upper tail side of the frame. The tail section is further down out of line, which has bulky compartments instead of the tail frame that provide lifting force, which allows them to be propelled upwards once engaged. Into focus throughout the use of the above-mentioned techniques. In other words, AIN has the vertical displacement capability and the section of the control surfaces that enables the B rotated on the axis, which is perpendicular to the longitudinal axis of the fuselage, the armament, and the best simple explanation would be to think of it in the bottom and the top view of the aircraft, the Hurricane. This is a Hornet that the pilots fly A and B Z as well. Now, notice that it does rotate. And here is another point through its design. The YF-23 was able to change and direct. I do believe that one of the factors to build the now, while most of the stealth technology on the F-35. The shaping of the F-35 aircraft is perhaps one of the greatest factors in its construction, and its stealth capabilities will be the so-called planned formed alignment as well as the radar absorbing coating, which are operational and battle-tested the surface of stealth military aircraft such as the F-22 Raptor and F-35 Lightning II. This decreased radar cross-section and so radar stealth with low observable. The aligned edges has reduced engine noise. F-35's aligned edges reduce the noise of engine internal weapon, and fuel helps to make it extremely unobtrusive. The F-35 is the apex of remaining undetected by the enemy and penetrating the enemy's airspace from the onset due to the complementing the rest of the structure's stealth engineering. NQ-239 electronic suite is integrated within the electronic warfare architecture of the ejection modular architecture. That technology and systems capable both offensive and defense capable of detecting the enemy medical emitters. Geoparsing TM for following this. Look at the weapon system. The F-35 fighter has 179,870,046 missions in order to incorporate forward-looking infrared and infrared-seeking F-35. The replacing stealth jam-resistant light infrared against and visual blocking flares and blast bearing contained with the F-35. The F-35 electro-optical targeting pod's primary visualization strategy enhances situational awareness for F-35 operators and enables air as well to displace facilities of interest, reconnaissance and violence through pinpointing facilities with a laser or GPS-guided ammunitions. It was among the first sensors designed to carry such weaponry, internally in stealth mode or externally in a permissive external weapons, low-threat mission environment in a situation where they don't expect to have any threats to their safety from hostile forces externally. The JASM will be carried by all models of the F-35, increasing range, lethality and survivability even against heavily defended strategic targets and increasing the ability to prevent near-peer adversaries from load. Martin developed the AGM-158 JASM Joint Air-to-Surface Standoff Missile System, which is practically an undetectable air-launched cruise missile system for the USA Armed Forces. It is a significant undercover long-range missile with an armor-piercing warhead with a weight of about 450 kilograms or 1,000 pounds. JASM can be controlled by the inboard station flares, chaff, and 2 decoys, stored in 2 compartments located behind the armament bay of the F-35 NBA weapons bays. 4 weapons stations. It has 2 internal weapons bays with 4 weapon stations. As to keeping its shape in stealth mode, the 2 outboard weapon stores may be loaded with 2 stores weighing not more than 2,500 pounds each, with the exception of the F-35B variant, whose outboard weapon stores load 2 stores weighing 1,500 pounds each, while the 2 inboard weapon stores are loaded with air-to-air missiles. JDAM bombs. JDAM variety of bombs. PON, the new Paveway series of bombs, joint standoff weapon, JSO and cluster munitions are all non-weapon types for the outboard station. And let us take a look at the constructed for use with the F-35 helmet, now sold for the price of $400,000. And this is a helmet-mounted display which gives the pilot critical flight information and also adds visor displays. And this is about night vision helmets. The helmet has a built-in data system that allows it to target faraway objects and even recommend which weapon suits the circumstance. Furthermore, everything deployed from the armory of the aircraft and in. This is the integrated digital night vision device. The pilot is already aware of the aircraft's 6 more cameras which are invisible to the naked eye, as the cameras are positioned at angle 180 degrees from where the pilot's head is turned. 9. The helmet is fed with data feed, which displays imagery from set of 6 cameras mounted on the F-35 airframe that move with the head of the pilot and help the pilot achieve even more realistic simulation, where their target imaging cameras are focused on and then N. So in case a pilot intending to hit a sorry missile, he can simply notice its target machine inside the aircraft and toggles to the particular area with just a slight movement of his head. Then the pilot is able to see straight through their own body and the floor of the plane to the terrain below. So, support their work and hit Radio Black Aviation. Let's aim to work together in bringing more content.